Let's just dive right into it. Today, we're cracking open one of the coolest custom mission frameworks in Arma 3, the Altis Mercenary Company, or AMC. We're going to use this massive script-driven sandbox as our ultimate case study to completely demystify Arma 3 multiplayer scripting. Seriously, if you've ever felt completely overwhelmed by how this engine handles multiplayer, you're in the exact right place.
But first, let me ask you a question that literally every Arma scripter has agonized over at some point. Why is it that your mission executes flawlessly in single player, but the second you load it up in multiplayer, it crashes immediately? It's the most frustrating reality, right? You spend hours tweaking in the Eden editor, everything's perfect, you launch with a buddy, and bam! Inexplicable errors everywhere. Today, we're going to figure out exactly why that happens, and more importantly, how to fix it for good.
So here's our roadmap for this explainer. We'll start with the absolute bedrock, the golden rule of locality. Then we'll hit script scheduling and execution, move on to multiplayer networking and security, and wrap it all up in the autopsy room by fixing common scripting mistakes.
All right, part 1, the golden rule, locality.
Let's define this super clearly because it is absolutely crucial. In multiplayer, an object like, say, a vehicle, a specific unit, or even a laptop can visually exist on every single machine. You all see it. But only one specific machine is authoritative for operations on that object. Think of the server as the game master or the campaign authority. The clients, so you and your friends, are the local actors. Just because you see a button on your screen doesn't mean your machine has the authority to tell the server what that button does for everyone else.
The AMC framework handles this split brilliantly. Things like campaign state, the economy, enemy spawning, that is all strictly server territory. But your player UI and action menus, those belong to each client individually. And moving or animating a player's physical unit, well, that belongs to the specific machine that actually owns that unit. AMC enforces these boundaries using what we call guard clauses. Basically, if a piece of server code somehow accidentally triggers on your client machine, this guard clause catches it and stops the code dead in its tracks. No execution, no cascading errors.
We can actually see this locality concept perfectly applied when it comes to saving data, or persistence. AMC intentionally splits up where data lives. So you've got the mission profile namespace, which holds the shared authoritative campaign save. We're talking the company bank account, captured sectors, the AI roster, all of that lives strictly on the server. Contrast that with the profile namespace. This guy holds the persistent data for an individual human player's custom loadout, and it lives exclusively on their client machine. So your personal kit follows you, but the overall campaign, that belongs entirely to the server.
Moving right along to part 2, script scheduling and execution.
Now let's pit two absolutely vital commands directly against each other, call and spawn. If you use call, you're basically commanding the engine to run that code right this second, in what's known as an unscheduled context. It literally has to finish before the rest of the game can move on. You'd use this for pure immediate math or quick validations. But if you use spawn, you're starting a script in parallel. This creates a scheduled context. So you're going to want to use spawn for loops, cinematic sequences, or really anything that requires the script to pause, wait, or sleep.
Which brings us to a massive hidden danger. remoteExec call inherently creates an unscheduled context, so you must never assume that code reached this way is allowed to sleep or wait. If you tell a script to sleep while it's trapped in an unscheduled context, Arma is going to throw a massive game-breaking error at you. And actually, this exact oversight is what caused one of the most notorious execution crashes in the whole AMC build, which we are definitely going to autopsy in just a few minutes. Okay, on to part 3, multiplayer, networking, and security.
Let's look at a practical cheat sheet for the remoteExec framework. When you need distributed machines to talk to each other across the network, you assign a target. Target 0 broadcasts to absolutely everyone. Super useful for global announcements. Target 2 sends the command straight to the server. AMC actually relies on Target 2 heavily. Like when a client clicks Buy on the HQ laptop, the client uses Target 2 to ask the server to handle that authoritative purchase. And finally, using an owner ID sends a command to one specific player, which is exactly what you need for private hints or personal UI updates.
But look, networking isn't just about sending messages willy-nilly, it's about doing it securely. When broadcasting public variables, AMC uses a final true flag to push the namespace publicly. More importantly, though, every single client request must be validated by the server using those guard clauses we talked about earlier. Seriously, do not trust the client. And for ultimate hardening, the absolute best way to restrict network commands as your mission matures is by implementing a config remoteEx whitelist.
This essentially locks the door, ensuring only specific pre-approved functions can ever be executed over your network.
All right, time for part 4, fixing common scripting mistakes. Let's head into the autopsy room.
Autopsy number 1, the sleep crash. Here was the symptom. Players hit the hard-earned victory condition, but instead of a nice celebration, they get slapped with an error suspending not allowed crash. The cause points right back to what we learned a minute ago. The victory sequence contained a sleep command for some dramatic timing, but it was triggered via remoteExec call, an unscheduled context. The fix they implemented is this brilliant defensive pattern. You simply check the engine command can suspend. If it returns false, the function just immediately relaunches itself using spawn to create that safe, scheduled environment. Boom, problem solved.
Another major bug during that victory staging brings us to this really hard lesson. The server cannot blindly control human-owned units. During that exact same victory sequence, the server tried to line up all the players for a cool cinematic shot, but the camera was totally ruined, and the cast of players appeared completely broken and scattered. Why? Locality. Human units are local to their clients. The fix here was realizing that locality is a non-negotiable design constraint. It's not just some optimal optimization detail. The server literally had to use remoteExec to tell each specific client, hey, move your own unit into the victory formation.
Moving on to autopsy number 2, the replaced objects bug. So players upgraded their HQ, which swapped out a basic folding table for a fancy high-tech desk and laptop. But suddenly, nobody could interact with the laptop to take new contracts. The cause comes down to object lifetimes. When the server deleted the old laptop to build the new one, it completely incinerated all of the player interactions attached to it. They just vanished. The fix was to build a persistent client-side watcher script. This script just hangs out, detects when a new HQ terminal appears in the world, and automatically reattaches those interaction menus.
And our final autopsy, number 3, looks at cascading engine errors. The symptom here was pretty terrifying. A contract generated a wildly invalid string, which instantly broke position commands, vomiting errors all over the map. The cause was eventually traced back to a corrupted save file that had loaded empty sector data. All the downstream scripts had just blindly assumed the data was a perfectly valid array of numbers. The fix here is an absolutely vital practice. You have to treat persistent and network data as untrusted, dangerous input. Validate the data at load time for sure, but then validate it again right before you use it to spawn anything.
So let's wrap this all up with 3 vital takeaways. First, locality. Always know exactly which machine, server or client, should own each piece of logic. Second, scheduling. Know for a fact whether your current code is running in a scheduled or unscheduled context before you ever try to use a wait or sleep command. And third, treat all persistent and network data super defensively. Arma is actually a highly logical, distributed system. Once you understand and respect these 3 rules, it stops feeling like mysterious black magic, and it starts behaving exactly the way you engineer it to.
We've broken down the architecture, we've navigated the strict rules of the engine, and we've autopsied some really tricky bugs. Now that you're armed with the framework of the Altis Mercenary company, what kind of company are you going to build? It's time to open up that Eden editor and start writing your own legacy. Thanks for joining me on this explainer, and I will catch you in the next one.